Alrighty. So what we're looking at is what's the part of the quadratic formula that's referred to as the discriminant. That's this part that's under the radical right here. Now, the discriminant isn't the square root, it's just that expression. The value of the discriminant tells you two things. It tells you the number of roots, and it's going to tell you the nature of those roots. Okay, so the nature of the root is it a real number or is it a complex number? Okay, not real numbers, which are all the numbers you've dealt with. Then you have a group of numbers called complex numbers that are made up of imaginary. So a complex number has a real number part and an imaginary number part. These you don't see, you can't see these on a regular graph. These don't show up on a regular XY graph. So if you looked for imaginary numbers on a regular graph, you'd never see them. Okay, now if you look at this Desmos graph here, okay, so if you look at all I'm doing is I'm just changing the numbers. These sliders change the values of these coefficients like A, B, and C. So right now, A is 1, B is 1, and I'm going to make C like 2. All right, now look at the discriminant. It's calculated right down here. So this would be 1 squared minus 4 times 1 times 2. So the discriminant is negative. How many real roots does this have? None, because it doesn't cross the x-axis. All right, now, if I take A, just make it negative. Now watch what happens to the discriminant. Okay, A was 1. Now I'm going to make it negative 1. And watch the discriminant in the last row. There it is. Now if you look at the discriminant, it's positive. And if you look at the number of real roots, there's 2 of them. Okay, now I can take A, turn it back to being positive again. Okay, I'm just going to move B around a little bit. So as you notice, as I move B around, watch the discriminant. It's negative, 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 negative. Okay, discriminant is now positive. So when the discriminant is positive, you're going to have 2 solutions. When the discriminant is negative, you're not going to have any real solutions. Now, what about if the discriminant was 0? So I'm going to set this so that it's 0. Let's put this back at 1. I'm going to get this as close to 0 as I can. Yeah. Oh. Why did I move it? Because I'm trying to get the discriminant to be 0. It's at 0.2. I don't think I can move it that fine. Oh, maybe if I did this. Oh, I just did that. Yeah, I'm trying to get b squared minus 4ac to be 0, and I can get close, but not. Can't get it exact. All right, that's probably as close as I'm going to get. So when if I could zoom in and I could get this just to touch. I can't. Okay, hold on. I got one more idea. Step 0.001. Which of this should work. Okay, now let's try it. Nope, it's just not fine enough. Okay, so I was trying to get B. I was trying to get this to be the discriminant. Oh, that's pretty close. So if you look at the discriminant now, it's 0.01. Now this has, if this was exactly 0, there'd be only one root here. It's actually 2 roots, but what I mean by that, what would be, if I was to factor something like that, it would look like this: x minus 3, x minus 3. X equals 3 makes both of those 0. So that graph would touch 1, 2, 3. It would just touch and go at 3. So it's really 2 roots, but they're the same. Okay, so the discriminant tells you that. So here's the 3 cases you have. If your discriminant is positive, you got 2 distinct real roots. That means you got 2 x-intercepts. Okay, so that's this case right here. All right, if the discriminant is equal to 0, then you have 2 equal real roots or 1 repeated root. It's the same thing. That means you just have 1 intercept, and the graph would look something like this. Okay, and then if your discriminant was negative, then you'd have no real roots, you don't have any x-intercepts, and the graph would look like this. So those are the differences. That's what the discriminant tells you. Tyler. All right, so if we looked at number 1, what kind of discriminant would you have? 0, greater than 1, less than 1? 0. So this symbol, this triangle is the Greek letter delta. And that symbol stands for discriminant. Brylan Wolmer? Brylan. Yes. Yes. Okay. Alrighty. Bye-bye. Get checked out. What? Brylan. All right. Just check, Brylan, check Google Classroom. It'll have the notes and the assignment on it. See ya. All right. So for this one, delta, the discriminant equals 0. Okay, how about the next one? Less than 0. Yeah. Pretty straightforward. Okay. So if you were given this quadratic, okay, so A is 1, B is 9. What value of K would make it so that it has 2 roots? So I'm going to set A, I'm going to set B at 9. Yes.
Could it be
Let's see. Okay, so that's 9. So this is what it looks like. And then we don't know what C is. That's what we're trying to find out. Okay, so it's asking what values of C would make this have 2 roots. So I'm going to make this negative. So right now, if you watch this, watch when it starts to have 2 roots. Right now, C is at 26. In our problem, C is K. That's the constant. Okay, so when C is 26, doesn't have any roots, doesn't have any roots. Oh, now it's got roots. Okay, and then once I get smaller than, looks like around 17 or so, it starts to, or 20, starts to have roots. Okay, so we want to find out what this exact number is. Yes, that's what we're going to do right now. Okay, so the first step that you go to, you want to figure out what kind of discriminant you're looking for. So we're looking for a discriminant that has 2 distinct roots. So that means the discriminant is going to be positive. Okay, so I set this up as b squared minus 4ac is greater than 0. And now I plug in my numbers. So there's my a, b, k is c. So I'm going to get 9 squared minus 4 times 1 times k is greater than 81 minus 4k negative 4k greater than negative 1. All right, now, when you are solving an inequality and you either multiply or divide by a negative, you got to remember to reverse the sign. So this is going to switch from a greater than to a less than because I divided by a negative, or if I multiplied by a negative. K is going to be positive, okay, 81 divided by 4. 20. Point 2. Point 5. Or 20 1/4. And we thought it was somewhere around 20 when we were doing it on Desmos. So if I set this exactly, now I should be able to get it exact. 20.25. And the discriminant is exactly 0. And if we zoomed in, there's just 1 root. It just touches the x-axis. All right, so x would be greater than, and you typically just leave it as if you can reduce it, you reduce it. You usually don't write it as a mixed number. When it's just a generic problem. If it was a real life problem, you would. Okay, so each one of these examples is just a different variable and a different type of discriminant. So our second one now is find the values of P such that the equation has two equal roots. So that means our discriminant is equal to 0. E squared minus 4. Yes. See those words I highlighted? See those words I just highlighted and I circled? Okay. Right there. Are you looking? Right there. So that's what I said it equals. I highlighted it and circled it. No, because then you wouldn't know what to set it to. Yeah, I see what you're saying. Because I'm like, what do you mean you don't see it? I'm circling it. Okay. All right, now I understand. Okay, now when you do your A on this, guys, is 2. That's A. Your B is actually negative 2P. So my A coefficient 2, my B coefficient is negative 2P. And C is 4. And now it's just a matter of plugging it in. And now I divide both sides by 4. Yes. Right, because here, 1, it was an equal, so I don't have to worry about that. But the only time you switch your inequality is when you ever divide by a negative or multiply by a negative, then that sign would switch to this and vice versa. That would switch to this. Okay, yes. Yeah, we still got to take the square root of this. Haven't finished it yet. So this would be P equals plus or minus, and then my square root of 8 is 2 root 2. So if P was either one of those numbers, that graph would be just, that quadratic would just touch the x-axis. Okay, and now the last one Find the values of m such that the equation has no real root. So if I go back up here, no real roots, it's negative. All right, so in this problem, A is wait a minute, messed up. I know, messed up. 4, okay, A is 3M. And now I'm going to have to divide by negative, which means I got to remember to flip the equality. Or multiplying. So if anything larger than 3 would make it have no real roots. All right. So you have 2 assignments. The one from yesterday, which was set U, and then these problems from today. Okay, so on the first part, on part 1 of today's, you're doing 1A, 1B, and 1E. Now it says use your calculator to sketch. So when you make use your calculators to sketch them, then find the value of the discriminant. State the nature of each of the roots. So when it says state the nature, that's when you're writing out, hold on. Okay, you guys over there be quiet. Almost done. Okay, when it says state the nature, that's when you're writing this stuff out. 2 distinct real roots, 2 equal real roots, no real roots. That's when they say state the nature of the roots, that's what you're talking about. When you make these drawings, notice it says to sketch. All right. So your sketch, stop goofing off over there. You're kind of a naughty boy, aren't you? Yeah, you are. You're, oh, look over there. You're always doing something. Yeah, kind of naughty, aren't you? Yeah. Not as innocent as you pretend to be. Okay, I'm giving you grief. Now, when you draw these guys, if it's got x-intercepts, show what they are. It can't be just a drawing without any numbers on it. Okay? If your parabola doesn't even cross the x-axis and it does something like that, make sure you're indicating what these numbers are. Okay, so if you turn in a drawing like that, it's not going to count. You got to label the points on your drawing. So that could be if there's intercepts, or a vertex and an intercept, or both intercepts. It's just not this. That doesn't cut it as a sketch. It really depends on what it ends up looking like. Let's try one here. So you got x squared minus 5x plus 9. Okay, now you could just do it on Desmos since it's a little quicker. So we'll use Desmos to sketch it. So let's see, -5 and 9. All right, so graph. Okay, so if I was sketching this, x, y equals squared minus 5x plus 9. Okay. Plus. All right. So I'm going to make that drawing. Now, okay, there's a y-intercept, so I'd label that, and I'd label that. That's what my sketch would look like. Just like this. Yeah, because on Desmos, it's so easy. I understand, like on, the TI, you got to do right bound, left bound, guess. But for this, you can just, Desmos is fine. So my, so that's what my sketch would look like. That's what I would expect you to turn in. Something like, that. So I'd put like 9 there. 2.5. Okay, that would be that passes. Okay, that would be fine.